Today we're going to learn how to make ions into compounds. We know that elements react by losing or gaining electrons to become more stable. The most stable configuration is a full valence shell. You can do this one of two ways. Atoms can gain electrons to obtain 8 valence electrons, or atoms can lose electrons to empty their valence shell to 0. The goal is to be either 8 or 0. This is known as the octet rule. Think about what other things have the word oct in it. Octagon, octopus. Hydrogen and helium are exceptions to this octet rule. Those elements are found in the first principal energy level. And from your last notes, you found that the first level can only hold 2 electrons total. So hydrogen and helium are happy with either 0 or 2 electrons. Ionic compounds are made of ions. Pretty easy to remember. Ionic bonds are formed when ions lose or gain electrons to form a neutral charge. When you write the chemical formulas, it's really important you put the cation or the positive ion first, and then the negative anion. I like to remember this because the cations or the positive charges are found on the left-hand side of the periodic table. The anions or the negative charges are found on the right-hand side of the periodic table. So it makes sense to go from left to right, positive and then negative. Let's try an example. First, we have sodium chloride. Sodium is found in the first column of our periodic table. We know that it has 1 valence electron. It's either going to want to lose 1 valence electron or gain 7. We know that electrons are lazy, so it would be a lot easier to lose 1 electron. That would give our sodium a +1 charge. Remember that electrons are negative, so everything is backwards. Chlorine is found in column 17. That column has 7 valence electrons. Is it going to be easier for chlorine to gain 1 electron or to lose 7? It's going to be easier to gain 1. If we gain 1 negative electron, we're going to have a -1 charge. Let's see what that looks like. Sodium has 1 valence electron. Chlorine has 7. Sodium wants to give up its valence electron, and chlorine needs 1 valence electron. So they become best friends by creating this bond of give and take. Sodium is giving its electron up, and chlorine is accepting its electron. They only need to transfer 1 electron between the two of them for everybody to be full and happy. So we would write the chemical formula as NaCl. Let's try another one. Let's try calcium bromide. Calcium is found in the second column of the periodic table. We know that calcium has 2 valence electrons. Is it going to be easier for calcium to lose 2 valence electrons or to gain 6? It's going to lose 2 valence electrons. When you lose 2 negatives, you become more positive. Think about it as getting rid of a bad friend. I mean, really, they're not your friend anyway if they're bad. But if you get rid of negative things in your life, you become more positive. Same thing here. If we're losing 2 negative electrons, we're going to become a +2 charge. Bromine is found in column 17. Oh, hey, it's the same column as chlorine. So it's going to have the same pattern. It's going to have 7 valence electrons, meaning it wants to gain 1 electron, having a -1 charge. Let's see what that looks like. Calcium has 2 valence electrons. Bromine has 7. Calcium has 2 electrons to give, but bromine only has space for 1 of those electrons. So this bromine is full, but calcium still has 1 that it needs to give. Remember that these atoms are not just singular. They hang out in big groups. So if we put calcium and bromine in a beaker or a container together, there's going to be a lot of calciums and a lot of bromines. So that means they have a lot to choose from. So another bromine is going to come along and say, hey, I'll take your electron. So now our calcium is happy. It's gotten rid of all it needs to get rid of. And 2 of our bromines are happy because they've each gained 1 from the calcium. So now these are all best friends. We're going to write the formula like this. We always write the positive first. Positive. That's an ugly S, which is the cation. We only have 1 of them. So we don't need to write a 1 here because in chemistry, by just writing the symbol, that already indicates 1. Then we're going to write bromine symbol. And we need to count how many bromines do we have. We have 1, 2 bromines. So we need to put a 2 here, and we need to make it a subscript, which means it's a little bit lower than the font. So calcium bromide's formula would be CaBr2. Now everybody's balanced. There's a great, easy method to show how to do this, and that's called the crisscross method. The crisscross method allows you a quick way to determine how many of each ion is in the compound. Okay, let's look back at our calcium bromide. So calcium has a +2 charge, and bromine has a -1 charge. When you're doing the crisscross method, you are taking charges and changing the number to number of things. And you can't have negative amounts of things. So when I do this, I have to take the absolute value of the charge. That seems to be the biggest common mistake people make. So I want to take the absolute value of the charges. And what you're going to do is switch them. It's kind of magical. So if I take Ca and Br and rewrite them again, and now I'm going to take the charges and switch them and turn them into the subscripts. So this 1 comes down here, and this 2 comes down here. Now again, we don't need to write the 1, so our final answer is CaBr2. So instead of having to draw the little dots every single time, the crisscross method is a quick, easy way to look at the numbers and figure out how many of each formula there is. Now, of course, this doesn't work every single time. There will be some times this doesn't work. Here are some examples. This method does not work when both of the charges are the same number but opposite sign. So in my example here, I have Ca +2 and oxygen -2. They're going to go ahead and cancel each other out. Calcium has 2 electrons to give, and oxygen has 2 spaces to take electrons. So they only need 1 of each. In my other example, Pb is lead. It's kind of hard to find on the periodic table. It's number 82. It is in column 14. Okay, so it's going to have a charge of +4. There's a lot of questions about column 14 and how do you know when it's going to be a positive or a negative? The biggest trick on this is if it's first, it's going to be positive. And if it's listed second, it's going to be negative. So my PB has a +4 charge and my sulfur has a -2 charge. If I switch them, I would end up with PB2S4, which looks great, but when you write chemical formulas, you want to write the simplest formula you possibly can. So this one can be simplified down to PBS2. I hope that this helps you trying to figure out your ionic formulas. Let me know if you have any questions.